Good morning, guys. We're going to get right to it. On this video, I will take you through the steps in hypothesis testing. We talked about just identifying the correct type of test, and then whether it's a one-tail or a two-tail solution. So let's go ahead and begin. I'm going to look at that first example. I know we've saw it, I don't know how many times. Let me bring those up a little bit. But it kind of makes things a little bit easier, kind of work in a format. That's pretty much what hypothesis testing is. Remember, the goal is you're testing a claim. So I'm looking at this claim right here. Okay. The claim was for ACT. The average ACT of entering freshmen is 23. You suspect this claim because after talking to a group of entering freshmen, it appears that it may be lower. So there's that keyword lower. To test the claim, you collect a simple random sample of 35. That specific sample has an average. There's X bar 22.1 with a sample standard deviation of 5.2. So that's the data that we found, or stats that we found. You visit the website. Oh boy, sorry. And find that the ACT population standard deviation, keyword there. Okay, it was 4.8. So I'm gonna run through this. I attached the chart, hypothesis testing chart, and I will bring that up on screen as well for this example, and then the attached assignment in Google Classroom, you will see that I've already done that for you. So there's your chart. When you go to classwork, there's the assignment. It's in PDF format. So yeah, I will upload the video. Hopefully you don't have any problems with watching the video. If you do, try going on to a different device, because it seems like it works for the most part. I'll have to talk to Gary about that. But anyway, so let's get back to it. That way I can post the video on here. So, first of all, we've already did this part. What type of problem is this? Okay. Let me just say it is a Z-test for sure. Okay. Definitely a Z-test. Why? Because we know this. Okay, so I'm going to write that down. Population, standard deviation is known. Okay. Now your assignment, you're going to follow along with the same thing. Okay. If it asks for what type of test, state what it is, state why. Okay. This part I may have problems with. Just being able to, maybe not, I don't know, I'll go for it. State the appropriate null and alternative hypothesis. Okay. Well, what we'll do is I'll just go for it. You'll state the null. Okay. Well, what is the null? I think I just made that too small. Hang on. Sorry. There we go. So the null hypothesis would be what? Do you remember what we put? Okay. The null hypothesis is saying mu. I'm going to spell it out here. Mu, the symbol mu. We're going to say, okay, this is the claim that we're testing. We're going to say that it's 23. Okay. Whatever this emissions director says, we're going to test it. Okay. Now remember, we identified this to be a one-tail test. Okay. The alternative of this is we think it's going to be lower than that. So the H sub A, okay, I'll zoom in on that a little bit, that way you can see it. I'm going to put mu is less than 23. Alright, so that's pretty simple, standard, okay. C, state the value of alpha, and it says A. Alpha is actually that fish shaped looking creature. If you don't have an alpha level, okay, you're gonna say your alpha level. Let me bring this down here. Okay, your alpha level is going to be 0.05. Think about the 95% confidence interval, or, well, if you don't know the confidence level, it's 95%. When you're running a hypothesis testing, okay, and you want to know the alpha level that should be used, okay, so that would be 0.05. Okay, so I think in the other two examples, okay, it gives you a level significance. Okay, that's the alpha level that they're talking about. You may or may not be given one. If you're not given one, go with 0.05. Okay, it's just like a 95% confidence interval. Okay, the next thing, I know I said quick and I'm not. It's Monday. Alright, so we're going to calculate the test statistic and p-value. So we'll go into our graphing calculator. Okay, we're running a z-test. Okay, there's our z-test right there. We didn't enter data. We do have stats though. Okay, so we're testing mu to be 23. We know the population standard deviation. Okay, let me move the calculator out of the way. Okay, the population standard deviation was 4.8. So I'm going to write 4.8 here. X bar, our sample mean, 22.1. That came from our simple random sample. And that was from a sample size of 35. Okay. And we're going to suspect, this is a one-tail test, okay, that it is less than or lower than 23. So we're going less than that. Okay, less than mu sub naught. Okay, then we're going to calculate. See what we get here. Okay. Well, those numbers look familiar. I think we did that in a previous video. So our Z test statistic, I'm going to write that right underneath here. Our test statistic, I still do that. I'm sorry. Is negative 1.11 or 109. So negative 1.109. Okay, and then our p-value. Okay, our p-value is 0.13365. Okay, So our p-value is equal to 0.13365. Okay. Guys, given our situation, we just did that. This part E here. Use your calculator to validate your results from part D. We're just going to stick to the calculator method. Okay. Now, these next three parts. Okay, this is everything. Okay. What is your decision? Okay. Now, I'm going to show you this chart right here, and off to the left of that chart, you'll see that we have two types of hypothesis, two-tail and one-tail. Okay, but then right underneath that, this two areas here, okay, this little guy, that's the alpha level. Okay, this is what's going to be used to make our decision. Okay, now here's what we are looking at. If p-value is less than alpha, the correct decision that we should make is reject the null hypothesis, H sub O. If for some reason our p-value is greater than alpha, and most of the time it probably will be, okay, I'm going to say most, I probably lied there. P-value, if it is greater than alpha, that means you'd want to fail to reject the H sub O. Okay, so that chart is very, very important, especially when making this decision. Now, here's how I usually set this up. Here's p-value. Okay. And then here is our alpha. Okay. Now see, our p-value is 0.13365. Sorry, I got some kids screaming in the background. Then we got 0.05 as our alpha. Now looking back at that chart, when you make that comparison, okay, we easily see that the p-value is obviously greater. Well, since p-value is greater than alpha, we're going to fail to reject. Okay, I'll just do this. We're going to fail to reject the H sub O. Now, there's something I want to mention on this. When you make this comparison, always have your p-value first on the left side and put alpha on the right. Okay, that way it aligns nicely with this chart. Okay. Okay. So, that was our decision. Now let's calculate the 95% confidence interval. Well, why would we want to do that? Okay. Well, here's why. This is why we did confidence intervals. We're going to calculate a 95% confidence interval. That and alpha work together. Okay. So, going to your calculator, when you go to stat test, okay, well, this is a z-test, I better run a z-interval. Okay, there's our z-interval. And see, our stats are already there. We got our population standard deviation. That was our sample mean in our calculator, or in our problem. There's our sample size. It has a confidence level for you ready to go. So all you gotta do is simply calculate that. Okay, so there's our confidence interval. So I'm going to write that down. Calculate the confidence interval. So, wish there was a way I could just copy and paste that. 20.51 and 23.69. Make sure I get this right. Okay, so there's our confidence interval. Well, now what? Think about the decision that was made. Fail to reject the H sub O. Okay. Think about this confidence interval. Think about our alternative and null hypothesis. Okay, this director made the claim 23. We think it's lower, and we took a sample size and the mean was lower. It was like 22.1, but that was just a sample size of 35. Okay, maybe that was not a large enough sample. Okay, but think about our confidence interval here. 23 is in there. Okay, that director's claim, okay, has 23 somewhere in there in between that interval. Okay, so when we interpret the result, okay, what would that look like? We are 95% confident, and I'm going to put this in front, based on our sample. We are 95% confident that mu, okay, what is mu? The average ACT scores of entering freshmen is between what? Those two numbers right there. Okay, so we're going back to what we did in the last unit, right? Now, what would that look? We got one more thing that we got to do. Okay, so there is not, this is our final statement here. There is not sufficient enough evidence that, okay, think about what we're getting ready to say here. State the null. That the director's claim is, I'm trying to word this in a way that kind of makes sense to people. There's not sufficient enough evidence that the director's claim is different from our observed sample mean. 23 is within our confidence. Oh my goodness, what is going on? I don't know what happened here, guys. My computer just got all crazy on me. Within our confidence interval. This is crazy. I apologize. interval. And something you want to might add into there at the alpha level. Okay. So, guys, that's pretty much the big picture. Okay. You calculate your z statistic and p-value. P-value's huge. Okay, you'll have that chart. Make the decision. Okay. Creating an interval, which we did in part G, and then interpret the result. And interpret based on our sample. We are 95% confident that mu, okay, go back to what we did in the last unit, and then the new interpretation, there's not sufficient enough evidence that the director's claim is different from our observed sample mean. Okay, we didn't have enough to say, oh, this is wrong, because there's not enough evidence that shows that director's claim is wrong. So, in a nutshell, we can't say mu is less than 23. So, the director's claim is plausible. So, I'll put that in green. Okay. So, we failed to reject this right here. Alright. Guys, stay in contact. I will check periodically throughout the day. My email I will check as well. Try those two attached problems for today's assignment. And if we need to start a discussion, go ahead and open one up. Until then, stay healthy.